Welcome back, everyone. Dr. Tom McNamara here for our course in trigonometry. In this video, we are going to discuss the concept of arc length. Okay, using the formula for arc length. You might actually remember this from our little video where we introduced radians. Now let me just draw myself a quick circle using my handy chalkboard compass. Doing my best to hold that steady. Okay, it's a pretty nice little circle there. So, just so we're all on the same page, we got a circle radius r here. We imagine a central angle theta. Okay, so going from the center out, the length measured along the circle from this point to this point. Okay, so the curved arc there. How long is that? That's what this is telling us here. Now, for this formula to work, you've got to measure theta in radians. Okay, so the arc length equals the radius times the measure of the central angle in radians. So if you know any one of those things, or if you know any two of those things, rather, you need two of the variables known. If you know any two of those, you can figure out the third. Okay, so let's look at a quick example right here. Find the arc length cut off by a 120-degree angle in a circle of radius 5 centimeters. Okay, so we're looking at this picture right here. Yeah, this is not a bad picture for our purposes. So if theta is 120 degrees, we'll convert that to radians. Okay, so there's a factor of 60 in each of these. 60 divides evenly into 120. It also divides evenly into 180, so the 60s cancel. 120 degrees is 2 pi over 3 radians. So the arc length S equals R, 5 centimeters, times my angle theta, 2 pi over 3. So 10 pi over 3 centimeters. That's the arc length cut off by a 120-degree angle. Let's do a couple more questions using this concept. Okay, let's do this. Let's look at this right here. I've got a little watch here. It was a Christmas present. I actually measured this. The minute hand on that watch is 1.5 centimeters long. How far does the 1.5 centimeter minute hand of that watch how far does the 1.5 centimeter minute hand of my watch travel in, let's say 40 minutes? Okay, so we're going to let 40 minutes go by. The minute hand is going to move round the perimeter of the circle. How far does the tip move? So that's what we're trying to answer. So the thing is, we need to know what angle is subtended in 40 minutes. Okay, so let me just draw a circle here. This is the kind of the circumference that the minute hand goes around right there. That's what that represents. So 40 minutes. What proportion of an hour is that? Now the reason I'm relating it to an hour is because in an hour the minute hand will go all the way around. Okay, so 2 pi radians in 60 minutes equals theta radians in 40 minutes. Okay, so I got to solve for theta in this proportion. And that'll tell me the angle I'm looking at. Okay, so I just multiply both sides by 40. So 40 times 2 pi over 60. Of course, that's a 2, that's a 3. So 4 pi over 3. That's my angle, theta in radians. So the distance, s, traveled by the tip of the minute hand, and I guess maybe I should put that in here. How far does the tip of the 1.5 centimeter minute hand travel in 40 minutes? Okay, we just figured out that if we wait 40 minutes, we have gone through an angle of 4 pi over 3 radians. So the distance traveled s would be r times theta, 1.5 centimeters, times 4 pi over 3. Oh, So, does this work out to be 2 pi? Right, because 1.5, there's 2 of them here, so this works out to be 2 pi centimeters. Oh, that's a neat little thing. Okay, cool. All right, one more problem. One more problem where we use the formula for arc length. So the space shuttle, let's imagine the space shuttle is orbiting the Earth, and it's 200 miles above the surface. So the space shuttle is orbiting 200 miles above the Earth. It makes a complete trip every 6 hours. Okay, so we're imagining we've got the Earth there, the space shuttle is above the Earth, we're orbiting the Earth. Of course, orbiting means we're going around, right? So a complete trip around takes 6 hours. So it makes a complete trip every 6 hours. How far does it travel in 1 hour? And this is a note that we'll need here, a little bit of information that we'll need. The radius of the Earth is approximately 4,000 miles. Okay, so the radius of the Earth is approximately 4,000 miles. Okay, now this drawing I'm going to make here is not to scale, but it'll give us the idea. So this is the Earth right here. Imagine that's the Earth. That's 4,000 miles. Okay, now the space shuttle is going around this outer circle. Okay, so I've got my space shuttle right over here. Do a little drawing of my space shuttle right there. Okay, so there's my space shuttle. Now, this circle is an additional 200 miles. Okay, so the radius of the outer circle that the space shuttle is traveling around is 4,200 miles, 4,200 miles. That's my radius. Now the question is, what's the angle? Okay, we want to know an hour later, we're going to be somewhere over here. The question is, what's that angle? Well, we know that the space shuttle makes a complete trip every 6 hours. Now a complete trip would be 2 pi radians. Okay, so I can find my angle theta by doing this. 2 pi over 6 hours is equal to theta over 1 hour. Solve for theta. In fact, it's actually already solved. Okay, so this tells me that theta would be pi over 3. Okay, that makes sense. 60 degrees. 1 hour goes 60 degrees. 6 hours, you would go 6 times 60, 360 degrees, or 2 pi radians. Okay, so I got my radius, I got my angle, so I can figure out the distance traveled, the arc length. R times theta, 4,200 miles times pi over 3 radians. I think 3 goes into 42. I think it goes in 14 times. 3 times 14 is 42. So this would be 1,400 times pi miles. That's the distance traveled in a single hour. Okay, so a couple of applications of the arc length formula. So S equals R times theta. The arc length is equal to the radius times the angle measured in radians. And if you know any two of them, you can figure out the third. In the examples we looked at, we were mostly figuring out S. We had R, we had theta, we found S. But it doesn't have to be the case. If you know the arc length and you know the radius, you can find theta. If you know the arc length and the angle, you can find the radius. Okay? Any two of them, you can always find the third.